Hello students, myself Dr. Ranjana Gogoi, Associate Professor in Statistics working at Gurgaon College. Today I am going to deliver a lecture on measurement of seasonal variations present in time series data. So this lecture is based on the syllabus of BSc 6th semester non-CBCS Statistics Major Paper Applied Statistics, which is taught in the colleges under Dibrugarh University. In this lecture, I am going to describe about the two methods of measuring seasonal variations of time series data. The first one is ratio to moving average method, and the second one is the linked relative method. The ratio to moving average method. The moving average eliminates periodic movements if the period of moving average is equal to the period of the oscillatory movements present in the series. Thus, for a monthly data, a 12-month moving average should completely eliminate the seasonal movements if they are of constant pattern and intensity. The method of getting seasonal indices by moving average involves the following steps. First, we have to calculate the centered 12-month moving average of the data. These moving average values will give estimates of the combined effects of trend and cyclic variations. Next, we have to express the original data except for 6 months in the beginning and 6 months at the end for the monthly data as percentages of the centered moving average values. These percentages represent the seasonal and irregular components if we consider multiplicative model. Thus, the preliminary seasonal indices are now obtained by eliminating the irregular or random component by averaging these percentages in averaging. Either arithmetic mean or median can be used. The sum of these indices S is not equal to 1200 for monthly data or 400 for quarterly data. An adjustment is done to make the sum of the indices 1200 or 400 by multiplying throughout by a constant factor, that is 1200 by S for monthly data or 400 by S for quarterly data, that is by expressing the preliminary seasonal indices as the percentage of their arithmetic mean. So the resultant gives the desired indices of seasonal variations. The merits and demerits of this method. The ratio to moving average method is the most satisfactory, flexible, and widely used method for estimating the seasonal fluctuations in a time series because it wipes out both trend and cyclical components from the indices of seasonal variations. An obvious drawback of this method is that there is loss of some trend values in the beginning and at the end, for which the seasonal indices for the first 6 months or 2 quarters of the first year and last 6 months or last 2 quarters of the last year cannot be determined. Our next method is to measure the seasonal variation is linked relative method. This method is also known as Pearson's method, which is based on averaging the linked relatives. Linked relative is the value of one season expressed as a percentage of the value of the preceding season. Here, the word season refers to time period. It would be mean month for monthly data, quarter for quarterly data, etc. Thus, for monthly data, linked relative for any month is equal to current month's value divided by previous month's value into 100. The steps involved in this method are: first, we have to convert the original data into linked relatives by the above formula. As in the case of ratio to trend method, average the linked relatives for each month or quarter of the data when the data are monthly or quarterly. Mean or median may be used for averaging. Then convert that average, mean or median, link relatives into chain relatives on the basis of the first season. Chain relative or CR for any season is obtained on multiplying the link relative of that season by the chain relative of the preceding season and dividing by 100. That is, CR for any region is nothing but LR of the region into CR of preceding season divided by 100. So thus, CR for the first season is taken as 100. Then for monthly data, the same relative for the first season, that is month, for January is taken to be 100. Then CR for February will be equal to LR of February into CR of January divided by 100. That is LR of February. Then CR for March will be LR for March into CR for February divided by 100. And similarly, now, by taking the December value as base, a new chain relative for January can be obtained as new CR for January is equal to LR of January into CR of December divided by 100. Usually, this will not be 100 due to the trend, and hence we have to adjust the chain relatives for trend. This adjustment is done by subtracting a correction factor from each chain relative. So if we write D is equal to 1 by 12 into second CR for January, that is new CR chain relatives for January minus 100 whole thing divided by 12, then assuming linear trend, the correction factor for February, March up to December is D twice D 11D respectively. So finally, the corrected chain relatives are adjusted to total of 1200 by expressing the corrected chain relatives as percentage of their arithmetic mean. So the resultant gives the adjusted monthly indices of seasonal variation. So what are the merits and demerits of this method? The linked relatives averaged together contain both the trend and cyclical components. Although the trend is subsequently eliminated by applying correction, the method is effective only if the growth is a constant amount or constant rate. That is, if the assumption of linear trend is valid. This method is not so simple as ratio to moving average method, and the actual computation of the linked relative method are much less extensive. This method utilizes data more completely than moving average method, as there is loss of only one linked relative, that is for the first season, while in case of moving average method it is not possible to get some of the values trend and seasonal in the beginning and at the end. So dear students, I conclude today's lecture here. Thank you.